Beneath the Geneva gloom, far below the world's surface, lies a stunning triumph of human ingenuity, and an unavoidable sign of potential destruction, the Large Hadron Collider, or LHC. It is a marvel of intelligent analysis, allowing scientists to probe the subatomic realm and triggering the discovery of the elusive Higgs boson, often dubbed the God particle. This innovation has captivated the scientific world. Yet, as renowned physicist Brian Cox once ominously declared, a hidden potential has been uncovered at CERN, sparking a wave of curiosity and concern. Could our pursuit of knowledge have led us down a dangerous course? Have we chosen an uncertain future, possibly one beyond our comprehension? Before delving deeper into this startling statement, it's essential to first take a look at the gigantic machine that is the Large Hadron Collider, managed by CERN. The LHC is a massive 17-mile ring of superconducting magnets and is by far the largest and most powerful particle accelerator ever built. It stands as the pinnacle of scientific accomplishment, capable of recreating conditions that rival the birth of the universe itself. This incredible apparatus allows scientists to explore the fundamental components of the cosmos. But with such immense power, could it lead us to unforeseen consequences, possibly even into uncharted and terrifying territory? Founded in 1954, CERN has become one of the most important and prestigious research facilities, boasting 23 member states and a vast network of experts. While the LHC is its most high-profile project, it is only one part of a wide variety of accelerators and detectors aimed at understanding the universe's smallest components. The LHC is a race to uncover the very foundation of existence. It accelerates protons to nearly the speed of light, sending them on a collision course that simulates the energy and conditions of the universe at its inception. The temperatures produced are millions of times hotter than the sun's core. A complex network of magnets guides these particles along their travel paths, while highly sophisticated cooling systems maintain the collider's ultra-cold environment, far colder than even outer space. The LHC is equipped with 1,232 dipole magnets that steer the proton beams and 392 quadrupole magnets that focus them. Another important kind of magnet helps make collisions more likely by pushing the particles together with incredible force. Essentially, CERN's mission is to collide particles with such precision that it is akin to hitting two needles placed 6 meters apart. The level of precision needed for this operation is stupendous. The technology involved is equally remarkable. The collider's construction features concentric rings placed deep below ground to protect them from radiation. To achieve optimal performance, the entire system is cooled to -456 degrees Fahrenheit, colder than the vacuum of space. 4 major particle detectors, ATLAS, CMS, ALICE, and LHCb, are stationed in the underground structure, each with a unique purpose in investigating various aspects of particle physics. These detectors are equipped with massive cameras that capture the particle impacts, with experts constantly analyzing the data in search of traces of the elusive Higgs boson. The Higgs boson is thought to be integral to understanding the very fabric of the universe, offering insights into its fundamental structure. In numerous ways, studying the microcosm can help us unravel the macrocosm of the universe, much like solving a massive, cryptic jigsaw puzzle. However, with each piece we place, new questions and mysteries emerge, reminding us that every discovery leads to another challenge. The LHC is not merely a scientific tool, it is an embodiment of human ambition, progress, and the relentless drive to comprehend the fundamental forces that shape our universe. But as we venture into the unknown, we must also confront the moral and existential dilemmas that accompany such daring exploration. What are the potential risks of delving into the unseen? Could our quest for understanding unleash forces we cannot control? In recent months, an unsettling revelation has sent shockwaves through the scientific community. Brian Cox, a former CERN researcher and prominent voice in particle physics, made a statement that both intrigued and alarmed his colleagues. According to Cox, the goal of the LHC, to recreate a version of the Big Bang in miniature, reproducing the very event that gave birth to our universe, could lead to unanticipated effects. The collider's impressive ability to probe the Higgs boson and explore the enigma of dark matter, a substance that makes up a significant portion of the universe, could potentially reveal information beyond our comprehension. While the concept of uncovering the universe's deepest mysteries is exhilarating, it is also fraught with risk. The LHC recreates the extreme conditions present at the universe's inception, simulating energies, pressures, and temperatures unlike anything we can observe in everyday life. It is as if we are peering directly into the moment the universe began. Yet, such immense power brings with it immense responsibility. Consider the incident involving Russian physicist Anatoly Bugorsky in 1978. Bugorski was conducting research at the U-70 synchrotron at the Institute for High Energy Physics when a tragic accident occurred. A proton beam accidentally penetrated his skull, causing significant tissue damage, but he miraculously survived, remaining conscious and seeking medical attention. His experience serves as a stark illustration of the potential dangers that come with particle accelerators. The power of these machines should never be underestimated. Concerns about the LHC's capacity to create black holes, albeit on a very small scale, have raised alarms among some in the academic community. Black holes are regions of space with such intense gravity that not even light can escape. Some scientists have voiced concerns that the LHC might create a miniature black hole, one that could theoretically consume the Earth from within. While CERN researchers have reassured the public that any black holes generated would evaporate quickly and pose no threat to the world, this hypothetical possibility has still sparked fear and intrigue. The idea of a black hole being created by high-energy particle collisions has been the subject of much debate and has contributed to the expanding awareness of the risks associated with such powerful experiments. Understanding the mechanics of the LHC is crucial for recognizing its capacity to produce a black hole. When protons are accelerated to nearly the speed of light and collide, the energy produced is so vast that it distorts the fabric of spacetime itself. This effect can be likened to jumping on a trampoline, causing the surface to bend. These distortions in spacetime have raised the unsettling question: could such shifts lead to the formation of a black hole? In the strange and mind-bending world of quantum physics, where the universe's fundamental laws appear to defy reason, there is a theory suggesting that unknown aspects of our reality might be concealed within the very fabric of space. If such elements exist, the LHC could potentially tap into them, sparking the creation of a gravitational anomaly capable of forming a void. This possibility has garnered attention from some of the most distinguished scientists in the world, including Stephen Hawking. In his writings before his passing, Hawking warned of the potential dangers of the LHC. As humanity continues to push the boundaries of what is possible, the LHC remains at the forefront of this exploration, a monument to our deepest questions and boldest ambitions. Yet, with every advancement, we must remain vigilant. The paradox of scientific progress is that the very tools that empower us to understand the universe can also challenge our notions of safety, reality, and existence itself. Ethicists and philosophers have long debated the implications of human experimentation on such cosmic scales. Are we equipped, morally, intellectually, emotionally, to handle the truths we may uncover? And if we are not, who decides what experiments are worth the risk? Where do we draw the line between progress and prudence? There is also the issue of public trust. As projects like the LHC grow in scale and complexity, the general public often feels alienated or unaware of the potential consequences. Transparent communication from the scientific community is more critical now than ever before. Public understanding and consent are foundational in a democratic society, especially when the experiments being conducted may, in extreme cases, affect the entire planet. Furthermore, the pursuit of knowledge must be weighed not only against immediate risk but also long-term impact. Could we be setting in motion events whose outcomes will not be known for decades, even centuries? Could future generations bear the burden of our curiosity? Despite these concerns, the LHC has already brought about incredible benefits. It has inspired a new generation of scientists, revolutionized computing through the development of grid networks, and led to technological innovations far beyond particle physics. It has also provided glimpses into some of the universe's most mysterious elements: dark matter, antimatter, and extra dimensions. These achievements underscore the importance of scientific inquiry, even when it carries with it the weight of uncertainty. Progress demands courage, not reckless bravery, but calculated, ethical, and well-informed risk-taking. That is what distinguishes exploration from exploitation. As we look ahead, the upgrades and expansions to the LHC, including the high-luminosity LHC, expected to come online in the coming years, promise even deeper dives into the structure of the universe. This next chapter could offer answers to some of the most profound questions ever asked. What is the nature of time? Are there other dimensions beyond our perception? Is our universe one of many? Yet, with each step forward, the duality remains: awe and anxiety, promise and peril, hope and humility. In the end, the Large Hadron Collider is not just a machine buried deep beneath the Earth. It is a mirror held up to humanity, reflecting both our genius and our recklessness, our yearning to know and our fear of what we may find. It reminds us that while we are capable of great things, we are also stewards of a fragile reality that we must treat with the respect it deserves. Because some doors, once opened, may never close. Considerations that come with exploring the unknown. As humanity pushes the limits of what can be discovered in science, the LHC remains an extraordinary example of our need to comprehend the universe. The sheer scale of the project speaks volumes about the ambition behind it. Over 10,000 scientists, engineers, and technicians from all over the world collaborate to ensure the machine's success. The amount of data gathered by the LHC is staggering, with experiments generating petabytes of data every year. The storage and processing power required to handle this immense demand for information has led to the development of cutting-edge technology that has revolutionized data and computing-related fields. The results from the LHC experiments go far beyond particle physics, extending into areas like medicine, material science, and even environmental studies. The study of the Higgs boson, for instance, could have far-reaching consequences that go beyond our current comprehension of the universe. The particle, integral to the standard model of particle physics, plays a key role in distributing mass to other particles. Without the Higgs field, the universe would be vastly different, with scattered particles in an empty, massless state. However, beyond the basic understanding of the Higgs, scientists are also keen to explore how the particle behaves under extreme circumstances. These studies could lead to insights that impact everything from the development of new materials to the understanding of the fundamental forces that govern the universe. One of the other critical aspects of the LHC is its exploration of dark matter. Dark matter is an invisible substance that makes up about 27% of the total mass and energy of the universe. Despite its immense presence, scientists have not yet directly detected dark matter. The LHC's experiments aim to expose the potential components of dark matter by observing the behavior of particles created during high-energy collisions. If dark matter is finally identified, it could change how we see the universe, unfolding hidden dimensions of spacetime and altering the foundations of modern physics. In addition to dark matter, the LHC is exploring other exotic realms, like supersymmetry and the possible existence of extra dimensions. Supersymmetry is a theory that proposes a connection between two fundamental classes of particles, bosons and fermions. It predicts the existence of superpartner particles that have yet to be observed. The discovery of supersymmetry could open the door to a new understanding of the fundamental forces of nature, offering deeper insight into the interactions that govern our world. Additionally, the LHC is essential in advancing quantum computing. By understanding the behavior of subatomic particles, scientists can gain insights that could revolutionize how we process quantum information. Computers operating in accordance with quantum mechanics have the potential to solve problems currently beyond the reach of classical computers. Technologies developed for the LHC's experiments, such as specialized sensors and cutting-edge computing algorithms, have already influenced the field of quantum computing, paving the path to future breakthroughs. Despite its undeniable benefits, the LHC's work also raises fundamental questions about the future of humanity. The search for the unknown can be thrilling, but it also comes with the responsibility of considering possible unintended consequences. The very technology that drives the LHC could be used for purposes that harm humanity, such as the development of advanced weapons or scenarios beyond our control. Ethical debates surrounding the LHC are not limited to catastrophic concerns like vacuum decay or black holes. They also include the responsible use of knowledge. How do we ensure that this knowledge is used ethically and that the pursuit of discovery does not inadvertently lead to harm? As we explore the unknown, it is crucial to engage in ongoing conversations about the balance between scientific progress and ethical responsibility. The fact that the LHC's work requires the cooperation of multiple nations, each with its own values, priorities, and concerns, adds complexity to the issue. Transparency in research, accountability, and international cooperation will be essential to ensure that the knowledge gained through these experiments benefits humanity as a whole rather than causing unforeseen damage. The work of CERN through the LHC serves as a reminder that achievement must always be tempered with careful examination of its broader consequences. Another issue of concern is the potential for unforeseen ecological impacts. While the LHC operates in a relatively contained environment, the large amounts of energy required are worth noting. The environmental footprint of particle accelerators, especially those that consume massive amounts of electricity and produce heat, could strain natural resources and ecosystems. Although efforts are being made to use renewable energy sources and improve efficiency, the broader question of sustainable scientific exploration remains. In the end, the path forward will require a delicate balance. The LHC represents humanity's drive for knowledge, exploration, and discovery. However, every scientific breakthrough necessitates ethical reflection and responsibility. The risks involved in such experiments cannot be ignored, but the potential rewards could reshape our understanding of the universe in ways we can only begin to consider. As we move forward on this journey into the unknowable, our focus must be ensuring that the pursuit of scientific progress is carried out in a manner that is safe, responsible, and beneficial for future generations. The Large Hadron Collider is much more than merely a tool for scientific investigation. It is a symbol of humanity's quest for knowledge and its boundless curiosity about the nature of existence. The LHC's work carries profound implications and significant ethical and existential considerations. However, it also demonstrates that through collaboration and careful oversight, humanity can unlock secrets that have the potential to change the course of history. As we stand on the precipice of these new discoveries, we must remain vigilant, mindful of the potential risks, and committed to the ethical use of the knowledge we uncover. In the end, the quest for understanding must always be guided by our responsibility to safeguard the future. The challenges ahead are not only scientific but philosophical and societal. As humanity peers deeper into the fabric of the universe, questions arise not only about what we can know, but also about what we should know. The pursuit of knowledge, while noble, is not without moral complexity. We must ask ourselves, are we prepared for the answers we might uncover? Could the truths hidden in the smallest particles of matter alter not just our scientific models, but the very way we perceive ourselves and our place in the cosmos? These are not merely academic considerations. The discoveries made at the LHC may one day affect global policies, economic models, educational systems, and even spiritual beliefs. The implications stretch across disciplines and borders. In this sense, the LHC is more than a collider, it is a bridge between what is and what could be. Every breakthrough opens a door to new technologies, but also to new responsibilities. Furthermore, the LHC exemplifies the power of peaceful international collaboration. In a world often divided by politics and ideology, this massive scientific endeavor stands as a testament to what humanity can achieve when united by curiosity and common purpose. Scientists from over 100 countries work together, transcending borders, cultures, and languages in pursuit of shared discovery. This unity in diversity is a powerful reminder of what is possible when cooperation triumphs over conflict. Yet, even as we celebrate these achievements, we must remain conscious of the potential disparities that could arise. Who will benefit from these discoveries? Will the advancements be shared equitably, or will they deepen the divide between those with access to cutting-edge science and those without? The ethical dimension of scientific progress must include not only safety and sustainability, but also justice and accessibility. Education plays a crucial role here. As the frontier of knowledge expands, so too must our efforts to make science accessible and engaging to the broader public. The findings from the LHC should not remain locked within academic journals or specialized communities. They belong to all of humanity. Public understanding and engagement are essential to ensuring that scientific progress remains accountable, democratic, and inclusive. Looking ahead, the future of particle physics and related sciences will depend not just on machines or data, but on our collective will to seek truth with humility and wisdom. The questions posed by the LHC are among the deepest humanity has ever asked. They remind us that, in the grand scale of the cosmos, we are still beginners, bold, curious, and full of wonder. Ultimately, the work at the Large Hadron Collider is a reflection of our species' most defining traits: imagination, tenacity, and an insatiable desire to understand the world around us. With these traits must also come caution, foresight, and compassion. Only by embracing both the brilliance and the burden of knowledge can we hope to chart a future that honors the profound responsibility that discovery brings.